today we're looking at Pascal's triangle to be able to expand binomials. Here's what I mean by expand binomials. If I had something like x plus y to the fifth, if I had something like x plus y to the fifth and I wanted to expand that, prior to today we'd have to go x plus y times x plus y times x plus y times x plus y times x plus y, and then do a lot of multiplication, which would take us a while to get through. Okay? So we're going to do the alternate method, which is so much quicker. And to do that, we need to start out by writing down Pascal's triangle. So go ahead and copy this down for me.
Did we do this last year?
Yes, you probably have seen it, hopefully.
I don't like this thing.
The people in first hour they acted like they hadn't seen it before.
I've seen
Yeah.
this. I don't enjoy it.
Acting like they drunk.
Okay, and this goes on.
Forever. I feel like I possibly may have not seen this.
You saw it.
Okay. Where?
See it.
Do you know my life?
In the Matrix?
I was talking to Casey.
Who am I?
You know the girl that put the
I don't like it because, like, mine it looks like 15, 10, 105, 1. My writing sucks.
It's hard to copy. I don't know how to draw.
It's one's down the outside.
Oh, I see. I see what's happening.
Slanted.
No, I'm not put together either. So.
Mentally
And then you would put
handicapped
20 under the
Egyptians made my pyramid.
15, 15. No, Mr. Moss called me fat. Coach White called me.
I was supposed to draw this.
Cole.
No, I'm just telling you that
And
it
Cole's called me
continued
every
on.
day.
Is what I was saying. I was trying to be smart, Alex.
Stupid.
He called like every day.
All right. So the pattern here is that I've got ones down the sides, and then to get the numbers on the inside, they come from the two numbers directly above it. So to come up with this 2, I added the two numbers directly above it. 1 plus 1 gives me the 2. To come up with this 3, I added the two numbers directly above it, which gives me 3. This 4, I add them together, gives me 4.
Oh, so those ticks are ones?
Yes.
These ones on the outside are 1.
The ones are what?
All right, in the middle, 3 plus 3 gives me 6. 4 plus 6 gives me 10. 6 plus 4 gives me 10, and so on. So that means the next term underneath 5 and 10 would be
15.
15, and then underneath this one would be 20.
Penny.
Okay.
Baby.
All right,
Would there be a 6
Mr. Troop got
there?
all giggly about this thing. He was like,
the next
It's
one
so
would be
cool.
1,
It
6.
goes on
Yes,
forever.
there would be a 6.
Can you not print this out?
Acting like they drunk.
that and that rectangle thing.
Here's how this is used. These lines, starting right here, they are the coefficients of what I would get if I multiplied a binomial out to this power right here. So if I had like x minus y squared, these right here would be the coefficients of the terms if I multiplied it out. If I had like x plus y to the third, these would be the coefficients of what I'd get after I multiplied it out. So
What do
let me
you-
show you what I'm talking about with
what?
something like just x plus y squared. Okay, if I'm going to multiply that, that's x plus y times x plus y. X times x gives me x squared. X times y is xy. Y times x is also xy. And y times y gives me y squared. Put these two together, I get x squared plus 2xy plus y squared. So if you look at the coefficients right there, they match up with 1, 2, 1.
Dude.
What?
So if I took x plus y cubed, the coefficient should be 1, 3, 3, 1.
How is it 1, 2, 1? How, yeah, how is
Because there's an invisible one.
There's a 1 right there,
Oh,
there's a 2 right there, and a 1 right there.
Oh,
sorry, I was thinking X.
So I get 1, 2, 1. So if I took the x plus y cubed and multiplied it out, my coefficient should be 1, 3, 3, 1.
Well, how do you know the exponents?
Very good. James led into it perfectly. He goes, well, how do you know what the exponents are of my variables. What happens is, with whatever variable is first, you start with the highest exponent. And then when I moved over, what happened to its exponent? It went down 1. So it went from squared to just 1, and then it went to 0, and anything to the 0 power is 1, so that's why there's no x here.
Did the next one be -1? No. Never
The
mind.
second variable starts at 0 and increases by 1. So y to the 0 is 1, that's why there's no y. This is y to the
1.
first, and then y to the
0.
second.
Or second, yeah.
So keeping that in mind, let's fill out x plus y cubed.
So you get
Um,
cubed
1.
So I'm going to have x cubed
plus 3xy
3x squared y
plus
plus
What?
3x
y
squared
yeah.
plus
y cubed.
y cubed. So if I took this and I multiplied it out 3 times, I would get that.
Well, that's great.
1, 2, 3, 0.
Why is this?
Where you-
How is this gonna help me in life?
0,
I don't see the.
Well,
Who?
not factor.
so it's
What about the 5? 1. What is
Since
that one?
this is a cube, I'm going to take this row of numbers.
You said this
right
is a
here.
cube.
After what?
I'm going to have a 1, a 3, a 3, and a 1.
After spring break, it's just
Because I have a 1, 3, 3, and a 1.
not gonna win it.
Then I'm going to start with this variable right here, and it's got to start with the highest exponent. And then I'm going to decrease every term. So I've got x cubed, I've got x squared, I've got x, and then I don't have x. The other one is going to go the opposite direction. It's going to not start, and then it's going to increase.
I don't want
So I don't have it, then I have it. I increase it by 1, gives me y squared. I increase it by 1, gives me y cubed. So one of them decreases its exponent, and the other one increases its exponent.
How do you know which one? Is it the first one that
The
does
first
it?
one is always decreasing. The second one is always increasing.
I don't like this.
What it first what?
The
Something.
first increases, the second decreases with its exponent.
Oh,
Ready?
you had like x plus y to the 16th. That's what you start with. And then just
You'd start with x to the 16th, then x to the 15th, and so on. Yes.
will you ever have like a trinomial for this stuff?
No, that's
Okay.
binomials. This is just binomials.
What happens when you use trinomials?
Oh no, this is binomial expansion, which means I've got to have a binomial.
You've never known trinomial extension?
I have not ever dealt with trinomial expansion.
Is it possible to do?
So I don't know.
4th hour.
Let's try another one.
Something you do not know. Wow.
There's a lot of things I don't know, Jared.
Is that supposed to be this or something?
No.
Oh,
Just 2x plus y to the 4th.
What?
And we're going to use Pascal's triangle to be able to figure out what 2x plus 4 to the 4th plus y to
You
the
just
4th power
threw
is
in a
if I
number.
multiplied it out.
Do you multiply Pascal's triangle by 2?
No, we're going to figure out what I have to do since there's a 2 there.
Wait, what?
Alright, so the first thing I need is I need the coefficients from Pascal's triangle that has a 4. So what are those coefficients?
1.
4, 6,
4, 1.
Okay, and it helps to give yourself some space. Alright, then, right here on the first one, what do I do to get the variable on the first one? I need the highest exponent, right? So what's my highest exponent? The 4th. But this time it's not just x, it's 2x. So I have to do 2x to the 4th power.
Why'd you put a 1 there?
Because that's the coefficient from Pascal's triangle. Okay, so the next one would be 2x to the 3rd, and it would be y to the 1st. The next one would be 2x squared and y squared. The next one is going to be just 2x, and it's going to be y to the 3rd, and the last one's going to be y to the 4th. Any questions there?
have plenty, but I'm not gonna ask you.
Because I thought that eggs increase.
The first, whatever's first decreases. Whatever's second increases. So now I need to do 2 to the 4th, which is 16. So I have 16x to the 4th. Here I have 2 to the 3rd, which is 8, and 8 times 4 is
Whoa,
32.
we're not done.
X to the 3rd y. Here I have 2 squared, which is 4. 4 times 6 is 24. X squared, y squared. I just have 2 times 4, which gives me 8x, y cubed, and then I just have y to the 4th
Where
thing.
did you get 16x?
Because 2 to the 4th power is 16.
You can do that.
Do what?
You're just like skipping past the x and going. I thought you had to do like.
No, you're just doing 2 to the 4th and doing x to the 4th.
Yeah, you gotta cube everything in there.
Oh,
And
I
you
guess.
gotta go to the 4th power of everything.
Multiply, so what you did on 32 is 4 times 2.
No, I did 2 cubed and then times 4. So 2 cubed is 8, and 8 times 4 is 32. You have to take care of the exponent first. So instead of going 2x plus y, 2x plus y, 2x plus y, 2x plus y, and multiplying that out, we can use Pascal's triangle and go straight to the answer much quicker. Let's try another one.
I only wish that we could break.
Alright, this time I have x minus 3y to the 5th.
Mom? Is that mom?
I got something.
Is that my mom? Hey, where'd you get the gum at?
Oh, was he calling mustache?
I think I got it first time. From home.
Alright, so what are my coefficients?
3.
1,
Oh.
5,
The heck?
10,
Never mind.
10, 5, and 1. Alright, we're going to write this one a little bit different because I think it'll work a little bit better. Alright, so let's do, I just want to do the exponents of the x first, and then we'll come back and get the y part of it. So what's the exponent of the x first? So we're going to do x to the 5th, x to the 4th, x cubed, x squared, and x. Okay, then I start with the 3y. So I'm going to have 3y here. I'm going to have 3y squared. I'm going to have 3y cubed. I'm going to have 3y to the 4th and 3y to the 5th.
You're doing
I'm
it.
just putting them underneath, so it may be, hopefully it's less confusing.
You should start from the right.
Alright, so 1 and x to the 5th give me x to the 5th. 5, x to the 4th, and 3y gives me 15, x to the 4th, y.
Okay, this looks a little bit better.
The next one gives me 3 squared is 9, 9 times 10 gives me 90, x to the 3rd, y squared. The next one, 3 to the 3rd is 270 times 10, which is 270, x squared, y cubed. The next one, 3 to the 4th is 81. 81 times 5 is what? Help me out on that.
I don't know.
What?
405?
400.
405. So 405 x y to the 4th, and 3 to the 5th is 243.
Wait, I feel like we skipped one.
Y to the 5th.
Why do we have one out? Why did we get 270?
How did I get 270? Because 3 cubed is 27 times 10 is 270.
Gotcha.
Now this one's different than the one we did earlier because it has that minus in there. If it has a minus, then the second term is negative, and then I alternate. So minus, plus, and minus. And I'll show you why that is. But if you have a minus, the second one is minus, and then you alternate. Here's why. I can write x minus 3y just like that right there. That's the same thing as x plus a negative 3y. So that means I'm putting a negative 3y in here, and I'm putting a negative 3y in here. So you should be able to see why this one is negative and this one is positive. Because here, what happens to the negative?
Goes away.
It's squared, and that's why I'm positive. Here I have an odd exponent, so that's why it's negative. Here I have an even, so that's why that one's positive. This one's odd, so that's why that's negative.
This time what threw me off is whenever you have to square the actual number and multiply. Are you always gonna have to do that?
If you have coefficients in here, then yes. You've got to, whatever your exponent is, you have to do it to the number.
You said if second number is negative,
The second term
second term.
is negative, and then that alternates from there. That's pretty much how you use Pascal's triangle. However, we're not always going to want to use Pascal's triangle because we're not always going to want to write Pascal's triangle out to figure out what row I need. So there is another way to get the coefficients that go, like in this case, 1, 5, 10, 10, 5, and 1. There's another way to get those coefficients. So that's the next thing I want to be able to do with you today is figure out how to get those coefficients. So stay with me, we're almost done.
Okay.
Oh, lordy lord.
You're like the only teacher where that works. They always have to do it 2 or 3 times.
Yeah.
You got that touch.
I do. Alright, now, we're going to represent each one of these coefficients with something. And I'm going to show you, and then I'm going to come back and explain what's going on.
Is that a C?
It is a C.
Why?
Alright, the C stands for coefficient. The first number is the power we're dealing with. So I'm dealing with the 5th power, so the first number is the 5th power. And then I go from 0, 1, 2, 3, 4, and 5. So I always start at 0, and then I increase up. So the first term is always going to be whatever power it is, 0. The second term is whatever power it is, 1, and so on. Okay? So this represents the coefficients that I'm looking for. Now, to get those coefficients, we have to use this formula right here, and don't freak out when you see this, like first hour did.
An exclamation.
You mean factorial, right?
Factorial. That exclamation point in math stands for factorial. Does anybody remember how factorials work?
5
I
plus
have
4
never
plus
heard that
3
word
plus
in my life.
5 times 4.
There you go.
Yeah.
If I had something like 3
Oh, shut up.
factorial, 3 factorial is the same thing as 3 times 2 times 1. So all it is you're writing down each number underneath it and then multiplying those numbers up. That's what the factorial does for you. Alright, so this is the formula we use to help us figure out our coefficients. Okay, this first number up here is my n value. The second number is my r value. So all I have to do is plug that in, and that'll tell me what coefficient should go in that spot. So,
Is this really on your calculator?
factorial's on your calculator. But you're not going to need it because nice things happen. I'm going to show you what happens.
I don't see it.
So, we want to verify that this is 10. So, what am I going to plug in for n? 5. So, I'm going to have 5 factorial on the top. Down here, I'm going to have 5 minus
1? No.
2, because I'm working on this one. My r is 2. So 5 minus 2 gives me 3. So this is 3 factorial.
2.
And then my r is 2 factorial.
You see.
5.
Now, here's the nice thing that happens. This 5 factorial is really 5 times 4 times 3 times 2 times 1. On the bottom, I have 3 factorial, which is really 3 times 2 times 1. And this one is 2 factorial, which is 2 times 1.
Where do you get the 3?
Coach White.
Where did I get this 3
Yes.
from? I subtracted these two numbers. 5 and 2 gave me 3. The nice thing that happens is that this right here and this right here are the same. So they can cancel. That just leaves me with 5 times 4 on the top, which is 20.
Oh my god.
And 2 times 1 on the bottom, which gives me 2, and ends up giving me the 10 that I'm looking for.
In what way is this simpler than the other way?
It's not. But
Then why are you showing us?
because what if they wanted a specific term on x minus 3y to the 10th power? I'm going to have to do Pascal's triangle all the way to the 10th power.
Don't you have a poster?
No, I don't have a poster.
Yeah, like, can you
Mr.
print them
Troop did.
off? Can I print one off? Why?
I'll go get you one, put it right there.
Because they're going to want us to find a specific term of x minus 3y to the 10th power, and then all I got to do is figure out which term it is, plug it into this, and then I'll know the coefficient that goes along with that term.
Ow.
Okay. Now, one thing I need to notice is what term is that one right there?
The third.
It's the third term. Notice how the third term relates to my r value. Notice that your r value is always what in relationship to the term? Your r value is always 1 less than your term. So keep that in mind when they're asking me to find a specific term. So, let me do one more example and then we're done.
So you have to do that for like every year.
For every term in there, yes. But when we use that right there, they're going to just want one specific term.
Stop bringing
Okay.
English into math.
So they're going to
You're
say,
doing that wrong. Yeah, every time I see that number, I'm just like, fuck.
they're going to say, here's something like x plus y to the 12th power. And they're going to want to know what is the coefficient of the 9th term.
Okay, what? Oh, I thought it was the 9 plus h term.
No, 9th term.
That's freaking out.
So they're going to say I have x plus y to the 12th, and they're going to want to know what is the coefficient to the 9th term. So if I'm wanting the 9th term, what coefficient do I want? What's the number on the left?
9, 12,
12, and what's the number on the right?
9.
8. Remember, your r value is always 1 less than your term.
How do you get that?
How do I get what?
8?
It's always 1 less.
Because this number is always 1 less than your term you're looking for. So if I want the 9th term, 9 minus 1 gives me 8. So this coefficient, this right here gives me the coefficient of the 9th term. So now all I have to do is plug those two numbers into this formula right here, and that will give me the coefficient. So n is 12, so that's going to be 12 factorial. N minus r, these two subtracted gives me 4 factorial. And then I have r factorial, which gives me that.
You ever have like 64 factorial?
We're not going to go that high,
Okay,
but
that's
you can
what-
do that. Then, what you always want to do is take the highest factorial you have in the bottom and cancel it with the top.
What?
So if I take 8 factorial and cancel it with 12 factorial, what's left of the top?
4.
There's 4 on the bottom, but what's on the top?
12, 11, 10, 9.
There you go. So 12 times 11 times 10 times 9 is left on the top. Let me go ahead and write that out on the bottom. So 4 times 3 times 2 times 1 on the bottom. So I go to my calculator. I'm going to do parentheses 12 times 11 times 10 times 9, and then divided by parentheses 4 times 3 times 2. And that gives me a coefficient of 443 over 8. What is that as a decimal?
Yeah, I didn't get that. I didn't even.
You didn't
Not
get that? Oh, I put a
495.
plus in there, sorry.
Coach
Hang
White.
on. I was going to say, I wouldn't think I'd get a decimal. There you go, that's better. I end up with 495.
Where does 443 over 8 come from?
It was an incorrect.
Are we having an
I
assignment?
I punched this in incorrectly.
We're having it.
I put a plus in front of the 9.
So all that equals 495.
All right, stop. Quit moving. Quit moving. Let me wrap this up, please.
Oh,
Yes, if I take those 4 on the top divided by these 4 on the bottom, I end up at 495. So what does 495 represent?
The ninth term.
The
The coefficient of the 9th term. So if I put the variables there that go with it, what would my variables be that went with it?
X. 8. X to the, the Y would be 9.
My y would be
To the X.
8. This is always going to match your second one. And this is going to be, what's that one going to be?
3.
4th, because these two things right here always have to add up to whatever your term is. Those two always have to add up to whatever your term is. So this is the 9th term of x plus y to the 12th. Say it again.
And like from that we would find the
Right. All right. We'll work on that on Monday.